Today I'm going to show you section 5.1, which is adding and subtracting polynomials. Let's begin by talking about what an algebraic expression is and what are the terms and coefficients. These are examples of algebraic expressions. And in this one, there really shouldn't be an equal to sign. So you've got 3x plus 2, and then you've got 4x squared minus x plus 5, and 9x squared plus y cubed. What we do with expressions is we simplify them, and we also evaluate them for a certain number. So for example, if you have 9x, you could actually evaluate that for x equaling 1, 2, 3, whatever number you want to plug in. So let's talk about what terms are. You have to count the number of terms in each expression. So for this one, there's two terms. We have a 3x and a positive 2. The terms are separated by pluses and minus signs. The coefficients are the numbers that are in front of the variable. So for this algebraic expression, 3 and 2 are our coefficients. So there's two terms. When you have two terms, we call that a binomial. I'm going to start talking about different types of polynomials. So if there's two terms, it's a binomial, bi meaning two. This next example has three terms. There's 4x squared, negative 1x, and a 5. There's three terms, and the coefficients are 4, negative 1, and 5. And the last, and by the way, that's a trinomial. Three terms is a trinomial. And two terms, we've got 9x squared and y cubed. There's two terms, and the coefficients are 9 and 1. Okay, so let's talk about a monomial. A monomial is a polynomial that has only one term, okay? So we could have monomials with just one variable, and on the next page I'm going to talk about if there's multiple variables. So there is two things we need to know. Three things. What does a monomial look like? These are all examples of monomials. There's one term. So you don't see plus something else or minus something else. These are each examples of what a monomial is. The coefficient for 2x to the fourth is the number in front of the x to the fourth, which is 2. So for B, the coefficient's negative 7/4. For C, it's negative 1. For D, it's positive 1. There's a 1. For E, the coefficient is 8. And for F, the coefficient is 0. Now, the degree of a polynomial is the highest exponent. So the degree of this is 4, 2. There's an understood 1 here. This is a 3. Now, this one, if you have just a constant, the degree is 0. But 0 has no degree. So it's kind of tricky, but 0 is the degree for 8. Now think of it as 8x to the 0 power, because anything to the 0 power is 1. This is equal to 1. So this is really 8 times 1. So when you see just a constant, the degree is 0, but 0 has no degree. Okay, so let's look at example 2. Example 2. Now, what are not monomials? Monomials do not have variables that have exponents that are fraction or negative exponents. So for example, 5x to the 1/2 power. If the exponent is a negative number, a fraction, or a decimal, it is not a monomial, okay? So the exponent has to be a whole number from 0 on, but it cannot be it cannot be a decimal, a fraction, or a negative number, okay? And for B, this is not a monomial because it has a negative exponent. Okay, let's look at example 3. What happens when you have a monomial? Now, this is a monomial. These are both examples of monomials, but there's two variables. To figure out the degree, what you do is you add up the exponents. So for A, the degree is 7. And for B, the degree is 1 plus 5 is 6. The coefficients are -4 and 10. So the degree, you add up the exponents, okay? So now let's talk about more specific different kinds of polynomials. So if there's only one term, it's called a monomial. If there's two terms, it's a binomial. If there's three terms, it's a trinomial. And these last two are examples of trinomials. If you have more than three, we just say it's a polynomial with however many terms. So here's some more examples of polynomials, and we're going to talk about their degrees. So for A is a polynomial. It has 4 terms. The degree, you're going to go by the highest exponent in the problem. The degree is 3. For B is a trinomial. We've got x squared, -8x, and 3. And to put it in standard form, x squared should be first, then -8x, and 3. The degree of B is 2. It's the highest exponent. For C, and by the way, that's a trinomial. There's 3 terms. For C, there's 2 terms, and the degree is +4. For D, okay, so now we've got multiple variables here. This is a trinomial. There's 3 terms. Now, the degree of the first term is 7. The degree of the second term is 5. You add these up, and the degree of the third term is 3 plus 1 is 4. So the highest number for the degree is the winner. So this is 7, so that's why the degree is 7. And that's a trinomial again. For E is a trinomial, and the degree of this is 5 because 3 plus 2 is 5. That's the highest, and this is 3, this is 0. So 5 is definitely the highest. For F, the degree is 0, and for G, again, it's no degree. And by the way, F and G are called monomials. Okay? For number 5, these are, again, examples of expressions that are not polynomials, and you need to know that. So for A is not a polynomial because it has a negative exponent. B, when you have a variable in the denominator of a fraction, that is not a polynomial. And by the way, in case you did not know, 4x to the third power is, and we're going to talk about this at another time, another way to write that would be 4x to the -3 power. To make up an exponent positive or negative, you move it from the numerator to the denominator and vice versa. So remember, you can't have negative exponents. And for C is not a polynomial because you have a power of a half. You can't have any fractions, decimals, or negative numbers. Okay, so now the next objective is how do you simplify polynomials? Because that's what we do with polynomials, is we simplify them and we also evaluate them. So for example 6, I'm asking you, can you add, this is the operation, adding up, this is a polynomial with 4 terms with a trinomial. So what you have to do is add like terms. So here is the easiest way to do this problem. And we can work vertically. You can drop the parenthesis here because you're adding, but I would take this 3x cubed and bring it underneath where it says x cubed. And then 4x, put it right under here, 4x, and then plus 1. Okay, so now we are combining by adding. If you combine these coefficients, you get -2x cubed and then plus 6x squared because you're adding 0x squared to this. And 4 plus 2 is 6x, and then -7 plus 1 is -6. So this is your new polynomial. It's in standard form because you have the highest degree, and then it goes down descending. And this is a polynomial with 4 terms. The degree is 3. The leading coefficient is -2. Okay, and that's a constant of that term. The next example is adding polynomials with 2 variables. So for this one, you've got 6a squared b plus 11ab squared minus 4ab. We are going to add a squared b. Now, a squared b is like terms with this one, a squared b. Negative 3ab squared, negative 3ab squared is like with this one. And 9ab, whoops, 9, that's an a, ab, 9ab. So now we're adding. So we're going to add 6 and 1 is 7. So 7a squared b. Do not change the variables. Plus 11 minus 3 is 8ab squared. Remember, keep the variables the same. And 5ab, because negative 4 plus 9 is 5. So now, this is a trinomial. The degree of this is 3 because 2 plus 1, this is 3, 2 and 1 is 3, and this is 2. So the degree is 3. And the coefficients are 7, 8, and 5. Okay? Now, let's subtract. How do you subtract polynomials? Well, what you have to do here, and this you have to be very careful, you are going to keep 6z cubed plus 2z squared minus 5 the same. Now, you're going to change, you're going to turn this into a plus sign, but you have to distribute this negative to all three of these. So this is going to be a negative 3z squared is 3z cubed, negative 9z squared plus z plus 1z and then minus 1. So I changed all the signs of these. Now, what's the highest power? 3 is the highest power. So we're going to add these coefficients. 6 and 3 is 9, 9z cubed. Those are gone. 2z squared minus 9z squared is negative 7z squared. Okay, then a z plus z, and then negative 5 minus 1 is negative 6. So this is a polynomial with 4 terms, and the degree is 3. It's the highest power. Let's subtract with more than one variable. So we've got 2p squared q plus 5pq squared plus pq. And now we're going to subtract. So I'm going to subtract this. So this goes underneath here. So it's negative 3p squared q. And we're going to subtract negative 9pq squared. And a negative negative is a positive 6pq. So now we're going to combine these two. These coefficients combine to be negative 1p squared q. These two combine to be negative 4pq squared. And there's an understood 1 coefficient there, and this is 7pq. So this is now a trinomial, and the degree of this is 3 because 2 plus 1 is 3, and also 2 and 1 is 3. That's the highest power. Okay? Now, what happens when you have more than one grouping, like in number 10? So what we're going to do is we're going to keep 3x squared minus 2xy plus y squared. We're going to subtract 7x squared. We're going to make this a positive y squared. And we're going to add 3xy minus 5y squared. Okay? So that's what we're doing. Now we want to collect like terms. So let's look at our x squareds. Okay, it looks like we have 3x squared and negative 7x squared, which is negative 4x squared. And I like to cross things out when I'm done combining them. Now as far as y squareds, I have a y squared here. I have a y squared here, so that's 2y squared. Minus 5y squared is negative 3y squared. So I got rid of that one, this one, and that term. And then we have negative 2xy and 3xy, which is a positive 1xy. And the degree of this is 2. 2, 2, and 1 is 2. So that's the highest power. And it's a trinomial. And the coefficients are -4, -3, and 1. Now, the last objective is what we also do with polynomials is we evaluate them. So we simplify them and then we can evaluate them. So in this next example, we are given this polynomial and they want you to do two things. Evaluate it for x equals 2. So what you're going to do is first look at the problem. Is there anything you can combine? And you can't. So because there's nothing alike here. It's already condensed. So all you're going to do is replace 2 in for x cubed. So 2 times 2 cubed minus 5 times 2 squared plus 2 and then minus 3. So now order of operations says you always do exponents first. So 2 cubed is 8. 2 times 2 times 2. That's 8. And then 8 times 2 is 16. 2 squared is 4. 4 times 5 is 20. And then plus 2 minus 3. And then now you've got adding and subtracting work left to right. 16 minus 20 is -4. -4 plus 2 is -2. And -2 minus 3 is -5. And you're going to do the same with -3. I'm going to plug -3 in here in this problem. So 2 times -3 cubed minus 5 times -3, we're going to square it, minus 3, because you're plugging -3 in there, and then minus 3. So -3 times -3 times -3 is -27, and -27 times 2 is -54. Minus -3 squared is 9. 9 times 5 is 45. And then minus 3 minus 3. So if we add these two up, you get a bigger, all of these are negative. So all you're going to do is add them up. 54 and 45 is 99. Minus 3 is 102. And then another 3 is 105. But it's a -105 because you're adding up all these negatives. So the answer to that is -105. So what do you do when you are evaluating and you have multiple variables? Well, simply you just plug in the number and do the order of operations. So 2a squared b would be 2. We want a to be -3. So -3, we're going to square it and then multiply by -1. And then we're going to add 3 times -3 squared and -1 squared minus 4 times -3 times -1. So order of operations, first do this. -3 squared is 9. 9 times 2 is 18. 18 times -1 is -18. Plus -3 squared is 9 and -1 squared is 1. And 3 times 9 times 1 is 27. And then -4 times 3 times, you have 3 negatives here, so it's a -12. So if we add these two negatives, you get a bigger negative. So that's -30 plus 27 is -3. Okay? In the last example, it's not really a story problem, but kind of. You've got monthly revenue from selling X clocks, and this is just an expression that was created for you. They just want you to plug 200 in this expression and explain the result. So if you plug in, they're saying they sold 200 clocks. How much money do they bring in? That's your revenue. So 200 squared, and this is all you're going to do, is it says -0.3 x squared plus 90x. And they want you to plug in 200 for x. So it's -0.3 times 200 squared plus 90 times 200. Okay? So if you square 200, you get 40,000. 200 times 200 is 40,000. And then if you multiply that by negative 0.3, you get negative 12,000. And then you're going to add 90 times 200. 9 times 2 is 18, and then add 3 zeros. So if you add these up, you've got a negative 12,000 plus 18,000 is a positive 6,000. So your revenue is 6,000 for this problem. That concludes section 5.1.